Okay, we have left at gravity definition yesterday. Right? So we have learned that gravity is something, right, that the force of attraction of heavenly body, as an imaginary force of some heavenly body of attraction, which helps or which does the role of attracting the object, okay, inside the gravitational field. Okay, gravitational field is is the work of gravity or gravitational force. So, that gravity is the measurement of gravitational force between a planet and an object on it and its weight of the object. On the planet. We have known that again. Whatever we measure about gravity, that is also a kind of weight. I thought weight. Therefore, gravity is the total weight now. Right? That's the definition. Gravity is the total weight of an object measured inside the gravitational field of a heavenly body. Again, if I'm measuring the weight of somebody, just for example, we have got a object which has got a mass of, let us say, mass of 40 kg. We have got a mass of 40 kg. And if we're calculating the weight, again, the calculating weight, that weight equals to mg by applying this formula, we calculate weight, mass 40 kg, and g, let us take it 10 meter per second square in round form. Then 40 into 10, it will be 400 Newton. The weight is 400 Newton. And the weight of that body is the same as that of gravity. The one here, gravity here, one that's right. They are same. The weight and the gravity are same. They are the same thing. We can calculate the gravity or weight of a body lying on a surface by using Newton's universal of gravity. Not only W equals to m. We can find the weight and gravity by using the formula of Newton universal of gravitation also. So we'll derive that formula later on. Again, we'll not go with that. We'll derive it later. Right? Now, effect of gravity. Right? We have got several effects of gravity that it holds atmosphere around the earth. Okay? As I told that due to gravity, the atmosphere of the earth is being held. It cannot escape out. Why? Because gravity is attracting that atmosphere, that all the air components. Right? And second, it develops acceleration to the falling ascending body. And we have learned that. We have learned acceleration due to gravity in the lower classes. While falling, while something is falling in the ground, right? Towards the ground, towards the center of the earth, it produces an acceleration, which we call as acceleration due to gravity. Right? That acceleration is being produced with the help of gravity. So that's why it has been given the name. They were acceleration due to gravity. Right? And it helps water to flow. And it helps water to flow also. And every object falls toward the surface from a certain height. Again, if we throw something toward the sky, okay, then at the same time it will fall towards the earth. Anything, or it may be something object which is hanging in maybe in the tree, like maybe the fruits hanging in the tree. When they fall, they always fall towards the earth surface. They never go off. Right? They will always fall downward. Everything, and it causes rain, hailstone, and snow. Due to gravity, rain will occur. And पानी positively got gravity got hailstone due to gravity, and snow also. It causes the revolution of planet and satellite, planet and around the star, and that of satellite around the planet. Again, planet revolve around this star. That is, we revolve, our Earth revolve around the sun, and moon revolve around the Earth. Why does that happen? Because the sun has got gravity, and that gravity is attracting the Earth. Right? The gravity is Earth. So that's why we are revolving around the sun. Right? And satellite also, that moon is revolving around Earth because Earth is attracting that moon with its gravitational force. Right? These are the effect. And the last effect, existence of solar system and other heavenly bodies. Everything in this universe exists due to gravitational force. Just for example, just imagine if there was no gravitational force of the sun, then there will not be this solar system. The solar system, all right, our solar system will not have existed if there was no gravity in the sun, right? Because every planet satellite will go here and there, okay? They will get distracted. They will start to move in their own way, okay? They won't move in orbit of move within it. And in any case, while moving in their own way, while moving here and there, they might collide with each other and they can be disappeared. Either gravity now, and the topic gravity of an object on the surface of the earth. These all the things you have known already, eh? About gravity. The thing which you don't know is in and the pitch. Right? So gravity, or also called gravitational force, the F is equals to weight, W is weight. Right there. That W means weight. They two are same. So that's what is written. Gravity equals to W is equals to GMM upon R square. Weight, W equals to gravity, or right, not gravity of weight, it is gravity or weight of body. And capital letter M means mass of the planet, while small letter M is mass of the body, and R is radius of the planet. Now look at it, it's quite similar to that of the Newton's universal law of gravitation. Right? Newton's universal law of gravitation, you have learned C M1 M2 upon T square, where M1 was mass of first body, M2 was mass of second body, and D was distance between their center and distance between them. Same here. Here M1 is the earth. The first body is the heavenly body. That's why this capital letter M is written as mass of the planet. And we have just let it differently. And you can, if we have written here M1 equal to mass of the planet, mass of the earth, then we would have written here GM1. But it has written M, capital letter M equals to mass of planet. So we have to write here G, capital letter M into what is second body? That is a object, that is a body, right? That is a small body which lies on the surface of the planet. I of that planet, the planet, the surface of the object like or object finds that body has got a small letter M mass. Right? So G MM upon R square, R means distance between them. And what the distance between their center? It is R. Again, that is the thing. Distance between the center. Look at it. The center of the earth and the mass. And it is equal to R. And just will neglect the radius of the body, right? Of this body on the surface of the earth. This will be neglected. We'll just take up the surface. Right? This is the what? This is the let us tell. This is the radius. This is the distance between the center. Right? So let me write down here clearly, right? So that you will understand and you will know what we are talking about. So yeah, we have known that already F equals to G M1 M2 upon V square. Okay, we have known it already. Right? Now let us take, as that of book, let us take a planet. We have got a planet and not exactly circle, not exactly spherical. Just remember it is spherical shape. And we have got the center. Let us make it a center. And add the, let us suppose the mass of this planet is capital letter M, as supposed by the book. It's capital letter M. Then we have got an object on the surface of the planet. Right? The planet is the surface man. Right? Ground level make we have got another body. Let us suppose that mass as small letter m. Right? We have got mass of that body as small letter m. And the distance between them is equal to r. Right? And we'll neglect this. Right? But we won't neglect everything. Right? Thus, in this formula, we are neglecting this. Now, let us keep it now. Yeah, simple. Let us tell here mass of first body. We are told that is m1 up to now. Right? It is m1 up to now. But now, yeah, we have let it with a different thing. The mass of first body is the mass of the planet. Right? The first body is the planet. In first body concept, तो नहीं किया ये बनेगा एउटा planet है right? And so we have consider the mass of planet with the capital letter M. I understood up here. Can you understand? Class 10 up to here. The mass first. Remember that the first part is the planet, and we have to consider that as capital letter M. Can you understand up to here or not? If you will not understand, then I can tell you again.
So,
Okay, others? Give me some response so that I can know. Can you understand or not up to here? बोलेगा वो बतियो माने के था. We're not telling anything. I would suppose that you have understood. Don't tell me that you haven't understood in online classes. Very later on. So yeah, mass of first body M1 equals to mass of planet. Again, similarly, mass of second body. Up to now, we have considered that as M2. Up to now, we have considered that as M2. But now, what is the second body here? Right? That is the mass of an object. The second body is an object, and we will consider that as M. Similarly, I distance, we'll talk about distance also. We are told that distance between the center, distance is d after now. Right? In Newton's universal law of gravitation, we have let distance is d. But now the distance, what the distance is? That distance between the two bodies is also the radius of planet. जुन planet को radius छ नि त्यो भनेको के हो? त्यही भनेको it is the distance, that is the distance भनेको right? So and we consider that as r. Right then, to got it up to here, we have just changed the denotation only, right? The thing is the same. In Newton's universal law of gravitation, we have taken two bodies, right? It could be anything. The difference here is that the first body is planet and the second body is object, and the distance will be the radius. That's the only difference created here. Right? Now let us write down. Let us replace those all the things. Right? Let us not replace G. It will always be the same. That won't change. Very G will always remain the same. Right? It will come in every formula in this portion. G. Now look at what is this M1? M1 is M1 is capital letter M. You can tell with me also. And what is M2? It is what is M2? What should we write instead of M2? What should we write? Small letter M. Okay. Letter M. Upon instead of D, what should we write?
R square.
R square. And yeah. Now instead of F, what can we tell? This is gravity, gravitational force, and gravitational force can also be considered to be as W, weight of the body. We have taken an object on the surface, so that's why yeah, it will come weight. Not always. If you are taking two bodies only and one body is not heavily body. है एउटा body के हुन्छ heavily body छैन भने it will be only force. त्यति बेला force मात्रै हुन्छ, gravitational force मात्रै हुन्छ. But if one is heavily body and another is object on the surface, एउटा heavily body हुनु पर्यो, planet पनि हुन सक्छ, it may be satellite also, and the will be the object on the surface, then we consider that as weight. So, now, from here, and now from this formula, we'll launch something, some other thing also. Where is that? Okay. Now, yeah, a little bit scripted part. Here, the radius of a planet is considered as the distance between the planet and the body because of negligible distance between the surface and center of the body. I told that, right? From the surface of the body to the center of that body. Okay, so body center we neglect that distance and we neglect this and this one. This a little bit this part. This from here to here, it will be negligible. It is negligible. This won't be taken into consideration because this is very much smaller than radius. Why do you neglect this? Because it is very much smaller than radius. So that's why we can neglect that. And similarly, the moon and other heavenly objects also have gravity as that of Earth. Again, I told that already, not only Earth, other heavenly body, other satellite also have got gravity. It's not only our planet which has gravity. There are other also. It has been proved that the gravity of moon is only 1/6 that of the Earth. That means it is 6 times lesser than that of Earth. Just for example, if the Earth has got 9.8, right? The Earth, the accessory gravity value of the Earth is 9.8 meter per second square. Then divide by 6, you will get the acceleration due to gravity value of the moon. Right? Or you can say if the weight or if the gravitational force of the Earth is, let us tell, 400 Newton to object. I have to object like it's a 400 Newton force like Tani Rasa and the gravitational force Rasa. Then it will be 6 times lesser on the moon, and then it will be 400 by 6. Right? It's always 6 times lesser. So it will be around 1.66, 1.67. Right? It depends on the calculator how you do. Therefore, a person who can jump 1 meter on the Earth's surface can jump 6 meter on the 6 meter high on the surface of the moon. Look at that. If we are able to jump 1 meter, right, in the Earth, then we are able to jump 6 meter high. That is 6 times more. Because why? Because the gravity of the moon is 6 times less. Right? This is very important for given equation. Whenever the things comes like comparing the weight of the Earth that it will tell something, right? The weight of the body on the moon is 6 times lesser than the weight of the Earth. Why? Or here also, a person we can jump 1 meter high on the Earth's surface can jump 6 meter high on the moon's surface. Why? It can to look at there. If a person can lift 60 kg on the Earth, he or she can lift 60 kg on the moon surface. Why? They all have got the same region. Why? Because the gravity of the moon is 1/6 of that of Earth. The same reason for all those give region equation because it is 6 times lesser. And that's why they can jump 6 times more. Right? Jump on success. So that they can carry 6 times more mass. Right? Mass. So that they will weight, they have weight 6 times lesser. Weight 6 times and that is the reason why everything happens. So now, this will come in the numerical part. I will do the numerical of this equation also. I any question have it numerical one got some. I will do that. So variation in gravity on the surface of heavenly body. We have got gravity and it depends upon following things from the formula. You can tell also the gravity depends upon the capital letter M. That is mass of planet or mass of heavenly body. It is directly proportional to mass of heavenly body. You will find quite similar to that universal law of gravitation. Right? In that also, it has told the gravitational force depends upon mass of first body. It depends upon mass of second body. Now, similarly, what is the mass of first body? The weight or the gravity depend upon mass of heavenly body. It also depend upon mass of an object. Right? We are taking on an object on the heavenly body, which is heavenly body much high. They are directly proportional. Similarly, it depends upon radius of heavenly body. In next page, we have got that. It depends upon radius of heavenly body, and the gravity is inversely proportional to square of radius of heavenly body. Right? Inversely proportional to square of radius of heavenly body. Right? That's the same thing. Right? This is variation of gravity on the surface of heavenly body. Now you can relate that again whenever the mass of heavenly body is more than the gravity will also be more. Just for example, if you compare the Earth and the, let us suppose, Earth and Jupiter. Okay, Earth is smaller than that of Jupiter. Earth has got less mass than that of Jupiter. So the Earth has got less gravity. I Earth much for a gravity. Similarly, mass of object on the heavenly body. If the mass of object is more, then there will be more gravitational force on that body. I tell like the body like the body gravitational force lagara tanye goncha. It will the heavenly body will attract that object with more gravitational force. So if it is more like if let us compare a bus and a car, and they have got different mass. The bus obviously have got more mass. So the bus will be attracted with more gravitational force. And just the bus हुन्छ त्यसलाई चाहिँ के हुन्छ बढी ग्राभिटीले तानिरहेको हुन्छ है त सिमिलरली कारलाई के हुन्छ थोरै ग्राभिटी फोर्सले तानिरहेको हुन्छ and similarly depends with the radius. Why it depends with the radius? Because radius keeps on changing in the earth surface. Okay, and the equator is different, in the polarity different. From that also you can make a conclusion that the radius can change. So that's why if the radius is less, okay, then at that point the gravity will be more. Just for example, the radius is less in the polar region, right? That is vertical, right? The radius is less. So that's why the gravity will be less at the polar region. Similarly, the radius is more at the equatorial region. So that's why the gravity will be more at the equatorial region. Right? So this one for today. Tomorrow we'll derive the formula. And if you have any question, you can ask me. And if you want this class